A few years ago, I made two solutions to do the classic iodine clock reaction. As you might be able to see, one of them didn't fare so well. There's a bunch of solid gunk floating around, so this solution is garbage. I wanted to see if the potassium iodate solution survived, so I mixed up a fresh batch of the starch solution. You can boil the water on a hot plate, but a microwave works just as well. Also, since the metabisulfite ion is hydrolyzed to bisulfite in solution, sodium bisulfite can be used as a substitute. I missed the footnote that says the solution has a 10 to 12 hour shelf life, so definitely prepare it fresh. The potassium iodate solution is a little bit easier to prepare. Once the solutions are prepared, it's pretty easy. In two beakers, measure out 100 milliliters of each solution. When you're ready to do the demonstration, pour one solution into the other, then back into the empty beaker to mix them, and wait. I'm using the potassium iodate from my shelf along with the freshly prepared starch solution. Being my first video, a little beaker shuffling is inevitable. Since I'm just testing solutions right now, I won't talk too much about the reaction, but briefly, the bisulfite is reducing the iodate to iodide, which in turn is oxidized to molecular iodine by the iodate. This happens slowly, but as soon as the iodine is formed, the bisulfite reduces it back to iodide. When the bisulfite runs out, the free iodine is left to react with the starch to form a blue complex. Let's just zoom in a little, and there you go. The color change is instant. Since now we know the starch solution has a limited shelf life, let's use up the rest. Here we go. Maybe. This beaker is shamefully dirty. It's not just the chemical storage that needs cleaning around here. This one's a little better. Oh well. We've got just over 150 milliliters of the starch solution left, so I'll transfer it to a large beaker. As a simple demonstration, the exact concentrations aren't critical, but if it's done to demonstrate reaction rates, that does become a factor to consider more closely. Let me measure out about the same volume of potassium iodate solution. Close enough. Okay. Now we just got to mix them together. I don't think I'll be able to pour this back and forth. I'd better get a stirring rod. Okay, here we go. Get the camera work ready from the start this time. I'm decent at chemistry, but this video stuff is harder than it looks. Alright. Add it in there. Give it a stir. This reaction is often used to demonstrate reaction rates because the time for the instant color change is predictable and varies proportionally to temperature and concentration. It's a classic demonstration because that's a surprising and dramatic result. I tried another clock reaction about the same time as the iodine clock, this one using a dilute solution of formaldehyde and a mixed sulfite bisulfite reduction mixture. Now I have no idea if either of these solutions are still good, so I have a few trials planned. We'll start with the solutions from the shelf. In this reaction, we'll add a pH indicator because as the formaldehyde is reduced, the pH of the solution increases. The indicators both start out yellow, and when the color change happens, the apparently same solution will become different colors. So I'm starting with 20 milliliters of each solution. Since there are two indicators, let's make up a second test tube with an equal volume of the formaldehyde solution. Right, equal volume. And I have 2 beakers, each with 20 milliliters of the sulfite bisulfite solution. In the test tube on the left, I'll add some phenol red. Uh-oh. This doesn't look good. I'll add some thymol blue to the one on the right. Okay. So these are both supposed to be yellow, and clearly they're not. So right away we can say the formaldehyde solution is no good. Let's mix up some fresh stuff. The instructions here are for a liter, but I'm only doing 20 milliliter tests, and we've already established that the solution doesn't store well, at least not for 6 years, so I'm only going to mix up 100 milliliters. Okay, I have 2 new test tubes with 20 milliliters of the fresh formaldehyde solution and the same 2 little beakers with the old sulfite bisulfite solution. Oh, great. Well, my concentrated formaldehyde is at least as old as the solution I just tested, so we could have bigger problems. Let's keep going anyway. And it seems like it wants to be yellow. Let's shake it up a little bit. It is definitely less blue than the last one, but not quite yellow. I know. Let's zoom in awkwardly to get a closer look. Maybe remove those beakers? Yes. It's definitely yellower than before. I have to say I'm a little bit perplexed because formaldehyde does polymerize over time. Mine does have some solids in the bottle, but the pH shouldn't get higher. This should be working. I am doing this on a smaller scale, so perhaps I'm just adding too much indicator. I'm going to try to add another 10 milliliters of the fresh formaldehyde solution. Interesting. There might be something to this. We'll keep it even, and I'll add 10 milliliters to the other tube as well. We seem to be on the right track. I'm going to add 2 more 10 milliliter portions to both, so it doesn't get too out of control. At that point, we'll call the orangey color that develops in the phenol red good enough to test the second solution. Another problem I discovered later is that the phenol red is almost 3 times more concentrated than the thymol blue. There's no way that I can fit 40 milliliters of both solutions in this test tube, so I'll grab a 100 milliliter beaker to do the reaction. Let's talk a little bit about what's supposed to be happening here while I leave the camera running like a rookie. The demonstration is designed to have 2 yellow solutions side by side. Another solution that's either colorless or yellow is added to it, and in a few moments one turns red and the other turns blue. There are a number of different variants for different effects. Okay, I'm back. Let's transfer the solution. Get the sulfite bisulfite solution back, and maybe zoom back out a little. Perfect. Since I lost count and thought I only added 20 milliliters to each test tube, I think combining the 2 sulfite bisulfite solutions will keep equal volumes. And mix. Let's clear things up a bit so we have a nice zoomed in clear shot of failure. While we watch this fail, let's talk about the reaction. Like the iodine clock reaction, there are a few things happening at the same time. First, the bisulfite ion attacks the formaldehyde and breaks the carbon-oxygen double bond. The sulfite does the same thing, but needs a hydrogen from a molecule of water, which leaves a free hydroxide ion floating around. This hydroxide reacts with another bisulfite ion to give a sulfate ion and regenerate the molecule of water. When the bisulfite runs out, the hydroxide ion accumulates and raises the pH. This in turn causes our indicators to change color. Like I said, there are a few more variants to this demonstration that use different indicators, and I do plan to cover those variants in a later video. This reaction should be about as quick as the iodine reaction, even with the mess up on volumes. The concentrations and reaction temperature change the reaction rate, so with the lower concentration of bisulfite, the reaction should actually be quicker. Since we've been already going at this for a few minutes, and this failure continues for another 45 minutes, let's just move on. This solution's pretty easy to prepare, so let's make up a new batch and wish I'd made more than 100 milliliters of the formaldehyde. Okay, so here we have the 50 milliliters of fresh formaldehyde solution that already has the thymol blue, and we're adding 40 milliliters of the fresh sulfite bisulfite solution. And it looks like it wants to do something. That is a beautiful color change. I've used the last of the formaldehyde solution and added the phenol red dropwise to get a nice yellow color. This is actually a bit lighter than it could be, but let's just see how it goes. Outstanding. It took some work, but we've got some nice colors after all. I think they need to be mixed a little better so the color change is more of a flash than a fade, but still, not bad. Well, there we go. I've gotten 3 bottles off the shelf, and I'm well on my way to cleaning up the storage room. In the next video, we'll talk about oscillating reactions. I have solutions prepared for 3 different reactions, and they've been taking up lots of space. Let's see if any of them are any good. Thanks a lot for watching, and I'll see you next time.